Hey folks, if you're absent today, it's Thursday, November 9th. Here's a quick rundown on what we're going to talk about in class today. Hey, we have a little SA quiz, summative assessment, Skyward assessment, whatever you want to call it. It's going into Skyward. And look, I'm going to put a number over here like 10, right? And then we know that the hypotenuse is twice as much as the short leg, right? This is the short leg. This is the long leg because it's across from the 60-degree angle, right? And this one's across from the 30-degree angle, so it's the short leg. So to get from the short leg to the hypotenuse, we got to multiply by 2 because that's the ratio between the short leg and the hypotenuse. And then between the short leg and the long leg, we got to multiply by the square root of 3. So we get 10 square root of 3. Now, I want you to think about this for a second. Do you think that mathematicians over the past, I don't know, 5,000 years only figured out 2 triangles, the 30, 60, 90 triangle or the 45, 45, 90 triangle? Do you think that's the only 2 triangles that we figured out in that amount of time? Of course not, right? So let me try to get a decent looking 45, 45, 90. You notice the program puts the little angle measures. I'm watching the angle measures here. Okay, so that's pretty close to a 45, 45, 90. If I knew the legs on the 45 were like 10 each, right? So let's put 45. We got to know it's a 45, 45, 90 triangle. Then I would know to get to the hypotenuse, I multiply by the square root of 2. Okay, so these are not the only 2 triangles that we know. So what do you do if you had some random triangle? So let's say like 57 degrees. You see how it says 57 right there? So let me put 57 right here. And let's put a right angle here. And then what was this one down here? I think it was 33, right? Because they've got to add up to be 180 degrees, right? So 33 and 57 would make 90. 90 more makes 180, right? So is it possible to figure out the ratios of the sides if we had this kind of random triangle right there? Well, let's use these 2 triangles that we know a lot about, to understand the ratios that mathematicians figured out maybe in the last 200 to 300 years. So let's look at the 60-degree angle for a second. Okay, let me change colors. Let's say we look at the 60-degree angle, and I want to know what the ratio is between the opposite leg. So opposite from the 60-degree angle, right? So let me put that down here, opposite. And then this leg right here is going to be called the adjacent leg right over here. So this one right over here is the adjacent leg. Now, adjacent to what? It's adjacent to the 60-degree angle that I'm focused on, all right? So let's put that down, adjacent to 60-degree angle, all right? And then this one's the opposite from the 60-degree angle. Now, in the future, we're going to leave off all that extra wordage from 60-degree angle, and we're just going to say opposite and adjacent. And I'm going to refer to the 60-degree angle in a certain way, and you're going to see that in just a moment, okay? So this ratio that I'm talking about is called the tangent ratio, the tangent ratio. So let's write the whole word out. Tangent is spelled like this, tangent. But mathematicians felt like it's too long of a word. So what they did is they abbreviated it down to tan, like that, like without the gent on there, right? But we still say tangent, whether you see it like this or whether you see it like this. So I was thinking about this word for a second, doctor, earlier today on my way to work. And I was thinking, quite often you'll see it like this, DR. But nobody says DR, they say doctor, right? So when you see an abbreviation like DR, you say the whole word, just like we see an abbreviation like TAN, but we don't say tan, we say tangent, okay? Now, we need to tell people, because mathematicians know what this means, what ratio we're talking about, but we need to tell people what angle we're focused on. So here's the way we write it down. We write down something like this, the tangent of 60 degrees, okay? So what we're telling people is we're going to get a ratio, okay, the tangent ratio, and we want to focus on the 60-degree angle. So the tangent ratio is equal to the opposite leg, opposite over adjacent leg. Now, do you notice I leave off the words leg? I just start saying opposite and adjacent because the hypotenuse has a special name to it, right? There is no opposite hypotenuse. It is the hypotenuse, okay? So The opposite leg and the adjacent leg, I just start writing opposite over adjacent. That's the tangent ratio. So when I say tangent of 60 degrees, I want you to focus on the 60-degree angle and then come up with what the ratio is between the opposite leg and the adjacent leg. So you could write 10 square root of 3 all over 10, but the 10s are going to divide out, and we end up with the square root of 3 for that ratio. Now I want to see if that's really true. So I'm going to go over to Desmos here, and I'm going to put that on your screen, and we're going to try this out. So I'm going to type into Desmos, T-A-N. Notice that it changed to that like italics font to a straight up font. It knows, it recognizes what I'm talking about. Then I'm going to open a parenthesis up, and I'm going to put down 60. And that's not what I was expecting right there. See, we just said that the square root of 3 is the tangent ratio. So here's something you need to be aware of. There's mainly two different ways that we can measure angles. One of the ways is using degrees, and the other way is called radians. So right now the computer, the calculator, is in the wrong measurement. It thinks I'm in radians, 60 radians, or just that, you know, right now we don't know what that means. So I'm going to go over here to my little wrench, and notice see radians is in that highlighted little box there. I want to switch that to degrees. And you notice it says tangent of 60 degrees. Oh, the ratio of the opposite leg to the adjacent leg is 1.73. Yes, it is. Beautiful. Okay. Now think about this for a second. It'd be pretty limiting if we only knew like one ratio. There's only one trig function that we knew. So first of all, put that one down. Tangent is the opposite over the adjacent leg. All right. Now you might be saying, well, what about this triangle down here? Well, we're going to deal with that in just a second. All right. Let's get the other ratios out of the way. All right. So we got the tangent ratio. Let's try the sine ratio. So if I say S-I-N-E, sine, you know that that is going to mean, well, first let's talk about the abbreviation. They drop one of the letters and they just put S-I-N. We don't say sin, we say sine, even though it looks like the word sin, but it's really the word sine abbreviated. And that ratio is the opposite leg. Notice I'm going to drop the word leg. I'm just going to put down opposite over adjacent leg. That's the sine ratio. Okay. Now, son of a biscuit, I'm not going to make a whole new video for this. It's opposite over hypotenuse. I'm just thinking about too many things right now. So the sine ratio is the opposite leg over the hypotenuse. So if I, let's say, focused on the sine of 30 degrees, let's just put it down just like this. I would want the opposite leg from the 30-degree angle, and I want the hypotenuse. Well, this is always the hypotenuse, but do you notice something here for a second? Look at this. Do you notice that the opposite leg from the 60-degree angle is this guy over here, but the opposite leg from the 30-degree angle is this one over here? So the opposite and the adjacent can switch depending on which angle I'm looking at. So let's see if I could grab the word opposite. Let's see here if it lets me do that. Okay, I'm going to try to, oh boy, I don't know if it's going to let me do that. I'm trying to highlight this guy right here. So what I'm going to do, I'm going to change my mind. I'm going to just erase opposite right here. Okay. Oh man, I hate how the triangle disappeared there. Son of a gun. Let me see if I can lock the triangle into place. And I'm going to erase the word opposite from here and 60 degrees, because now we're talking about a different angle. See how we're talking about the 30-degree angle? And I'm going to erase the adjacent over here because this switches. So I'm going to put now opposite over here, opposite from 30, and hypotenuse. The hypotenuse is always going to say the hypotenuse. But how big is the opposite leg? Well, it's 10, and all over the hypotenuse, which is 20. So that gives me 1/2. Now I'm coming up with some ratios that I hope we're kind of familiar with or easy to see. This one maybe is a little harder to see, but let's try that out right now. Sine, look, notice it just changed the font. It knows, oh, you're talking about the sine function. Yes, I am. 30 degrees, look, it's 0.5, right? So would it matter if, like on the quiz, I wouldn't have given people a 10 for this side? Let's say I would have given people 15. Okay, so this would have been 15 square root of 3, right? And this would have been 30 over here. So instead of 10 over 20, we would have had 15 all over 30, right? Doesn't that equal 1/2 still? So the sine ratio is always going to be the same thing for a particular angle. It doesn't matter what size triangle you have. That ratio is always going to be the same. That's going to be a real useful tool to deal with. Okay, let's get the last one down. If I said cosine, cosine is abbreviated like this, COS. And that means the adjacent leg over the hypotenuse. Adjacent leg over the hypotenuse. And if we're doing adjacent leg, like let's say we do cosine of 30, my adjacent leg was, well, in this case, 15 square root of 3, 15 square root of 3, all over 30, right? And so that reduces down to square root of 3 over 2, because 15 and 30, that makes 1/2, right? So my 2 is in the denominator. So I'm going to see if the cosine of 30 is the same thing as the square root of 3 over 2. So let me put that on the screen here. And I'm going to do cosine 30, and I get this 0.86 number. Let's see if that's the same thing as the square root of 3 divided by 2. Oh, look at that. Same exact thing, right? So in today's assignment, they say put it as a decimal or put it as a fraction. And so, you know, it's going to be somewhat tricky if they say put it as a decimal and they don't kind of specify what to round to, because, you know, this is an irrational number. It keeps on going forever, no pattern to it. So hopefully they tell us, you know, what place to round to. And I'll make that real clear in class today. So you check your homework and see if everything's going okay. So let's go back to this problem. How do you use that information? Well, let's say we knew we had this kind of triangle, and we knew this side was 10 long, and we wanted this side right over here, the x side, right? So I could use either the 57 or the 33 degree angle. And let's say I use the 33 degree angle. I've got to identify what side the 10 is and what side the x is. That's really, really important. So this is the hypotenuse over here, hypotenuse. Oh boy, hopefully I'm spelling this right. And this over here is the opposite leg, right? So we've got to go back and we got to find our ratios here. Hopefully this is not too messy. The cosine is the adjacent over the hypotenuse. The sine is the opposite over the hypotenuse. And the tangent is the opposite over the adjacent leg. So which one do we have? We have the opposite leg over the hypotenuse. So start looking around. Which one's the opposite over the hypotenuse? It's the sine function, right? So I'm going to go sine of 33 degrees is equal to 10 all over x. All right, so let's open up Desmos again. And oh shoot, I want to move this over a little bit so we can see, come on, so that we can see our problem here. All right, here we go. So I need to figure out how do I use Desmos here. And I'm going to come over here and I'm going to go sine 33. Now, just for my homework, I want to put that ratio right there, 0.54 something, right? So it's like 0.54 something, and I'm going to put 10 over x, all right? So you might say, what's he talking about just for my paper? Well, I'm not going to use actually 0.54. I'm going to use what Desmos has because it's more accurate than 0.54. The only reason I put this on my paper is because it's something I can deal with. I could think about 0.54 as 0.54 over 1, and then I could cross multiply. We've done a ton of this, right? So I get 0.54x is equal to 10, and then I'm going to divide both sides by 0.54. So let's do that right now. So I divide by 0.54, divide by 0.54, and I get x is equal to, let's jump back over here. See, I want that number divided into 10. So I could come down here, I could say 10 divided by, and then I could copy this number right here, Control C, Control V. That gives me my final answer, 18.4. Okay, now I round to the tens place or whatever place they want me to round to. So I'm going to say 18.4. I'm going to double check Desmos, make sure I've rounded correctly. It looks like I have, right? And I'm pretty happy with that. So what did that take? It took me deciding which one of the 3 trig functions to use. Okay, let me go back over here and summarize this real quick. I had to decide what did I have in my triangle, and I decided I'm going to use the 33 degree angle. I've got the opposite leg in the hypotenuse, so I decided I'm going to use the sine function, and I set it up correctly. This is my setup. I expect everybody to put a setup down on their homework. Okay, this is what the setup looks like. And then the solving part, This is kind of tricky. If the x is in the denominator, it gets a little trickier than if the x was in the numerator. Could I force the x to the numerator? Not with these three functions alone. Okay, I was forced to put x in the denominator because that's what the sine function tells me to do, opposite over hypotenuse. Okay, could I try using the cosine function? Well, yeah, I could. Let's see if that changes things. If I use the cosine function, I get 57. I want to focus on the 57-degree angle because this is the adjacent leg. This is the hypotenuse for the 57-degree angle. So I'm going to say 10 all over x. And then let's go back over to Desmos, and I'm going to do the cosine of 57 degrees. And do you notice it's the same as the sine of 33 degrees? So I'm right back to the same ratio, that 0.54 business. 0.54 equals 10 over x. It's almost like a miracle. How did they figure this stuff out? It's pretty cool. In pre-calculus, we spend like 2 to 3 months just, figuring out sine, cosine, tan, all kinds of different trig functions. So this is just going to scratch the surface. I went super fast in my video today. I hope it's useful for those people that are absent. I hope you can try some of the homework problems today and figure them out. Good luck.